In this last video, we are going to graph three functions, and we're going to try to use our transformation knowledge to translate some parent functions. So for y equals log base 3 of x plus 1, I'm going to graph. I'm going to write these steps out for you. I'm going to first graph y equals 3 to the x. And as you get better at this, feel free to skip a step. So I'm going to graph y equals 3 to the x because we have a base 3. The inverse of log base 3 would be 3 to the x. So graphing y equals 3 to the x would give me a 0, 1, a 1, 3, and a 2, 9. Now I'm not going to connect those dots. I'll even put the negative 1, 1/3 in there. I won't connect those dots because that's an exponential function and we want to graph this log function. But I'm using those so that I can reverse the inputs and outputs. So reverse the x's and y's. Reverse the x's and y's and replot. So instead of negative 1, 1/3, I'm going to have 1/3 negative 1. And then instead of 0, 1, I'll have 1, 0. 1, 3 will become 3, 1. And 2, 9 becomes 9, 2. And now the blue dots reflect the logarithmic function, okay? So I'm closer to graphing y equals log base 3 of x plus 1. This plus 1 on the inside means left 1. So my vertical asymptote, which is normally at x equals 0, is going to be moved left 1. And each one of these points will translate left 1. And then I'm going to connect the dots. And I've got my graph, y equals log base 3 of x plus 1. If I want to clean things up, I'll just go through and I will erase any other dots that are not part of the line or the curve. My domain, I can see from my graph that it's going to be everything greater than x equals negative 1. So I'm going to be negative 1 to infinity. The range is always negative infinity to positive infinity. The intercept is 0, 0, and the asymptote is at x equals negative 1. Now there's something else I want to show you here, and it has to do with the argument. Your domain will always be your argument is greater than 0. So in this case, my argument is x plus 1. I'm going to set that greater than 0. X is greater than negative 1. In interval notation, that's negative 1 to infinity. The other is your asymptote. So your vertical asymptote will always be your argument set equal to 0 and then solve. So my argument being set equal to 0, that would be x plus 1 equals 0. And then when I solve, I get x equals negative 1, and that's my vertical asymptote right there. Okay, the better you get at logarithms, the more you're going to see key values of your argument helping. For instance, log base 3 of 1, log base 3 of 3, log base 3 of 9, log base 3 of 27, and so on. So these right here are powers of 3. So log base 3 of 1 is 0, log base 3 of 3 is 1, log base 3 of 9 is 2, log base 3 of 27 is 3. That means that when my argument is 1, I'm going to get a 0 for y. So here's my argument, here's my y value, my output. So when the argument, I'm not seeing the input, when the argument is 1, my output will be 0. Well, how would I get this, right, to equal 1? That's if x equals 0. So if x equals 0, I will have a 1 in the argument. When x is 0, I'm going to get a 0 out. How would I get this argument to be a 3? Well, x would have to equal 2. So when x is 2, I'm going to have log base 3 of 3. 2 plus 1 is 3. Log base 3 of 3. So when x is 2, I'm going to have a 1 as my output, and so on and so forth. How would I get this to be a 9? Put an 8 in for x. So when I put an 8 in for x, I'm going to have a 9 in the argument, and log base 3 of 9 is 2. So when I put an 8 in, I get a 2 out. 8 in, 2 out. So you will get better at that part the more you use logarithms. Let's sketch the graph of y equals log base 3 of 3 minus x. This has some transformations in there that you're probably not used to, but you should get comfortable with. So I've got y equals log base 3, and I'm going to rewrite this. Y equals log base 3, and I'm going to write it negative x plus 3. And I'm going to go even a step further. Now that I can see that that x on the inside is negative, I need to see what that negative on the inside was a negative of. What was it a negative of? Y equals log base 3. I'm going to factor out the negative, and it was a negative or an opposite of x minus 3. So this negative is a reflect over y. This minus 3 on the inside is a shift right 3. So I'm going to take my y equals log base 3 of x, and I'm getting better at graphing y equals log base 3 of x. 1, 0, 3, 1, 9, 2. And I'm going to reflect over y, reflect over y, reflect over y, reflect over y. So I reflected each one of those points over y, and now we're going to go right 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. When we go right 3, I believe my vertical asymptote is going to go over to x equals 3. I'm going to check that by taking my argument and setting it equal to 0. 3 minus x equals 0. 3 equals x. That right there is your vertical asymptote. X equals 3. So I'm going to connect those red dots now that I've got it right. I'm going to erase the ones I don't need, including those original ones, right? There we go. And I'm going to fill in the domain from the graph goes from negative infinity to 3. I'm going to check this by taking my argument and setting it greater than 0. So 3 minus x is greater than 0. I'm going to add x to both sides. 3 is greater than x, which means x is less than 3, and that indeed is negative infinity to 3. My range for logarithms is always negative infinity to positive infinity. I have two intercepts, one at 0, 1, and the other one at 2, 0. And my asymptote is at x equals 3. Now this one, I think, is a good one for you to try. So go ahead and press pause, and you can try it. I am going to start doing the problem right now. So I see the transformation of up 1. So I'm going to take my y equals log base 3 of x, which once you do this graph, y equals log base 3 of x, once you graph that base a couple of times, you get really used to it. 1, 0, 3, 1, 9, 2, especially if you know your exponents. And then I'm going to take each one of those points and we're going to shift it up 1, up 1, up 1. And that I should have shifted down 1. However, I remember from the earlier problem, I was able to go 1/3 down 1. And I don't know if you remember that. Let me put that in gray. Let's see. I've got it over here. There it was. So, yep, 1/3 down 1. So I'm going to plot that one right here because that one's going to come in handy. 1/3 down 1. So when I shift that one up 1, look at that. I know exactly where that is. That's going to be 1/3, 0. That's an intercept. 1/3, 0. So using prior knowledge is helpful. We've got x equals 0. Shifting a vertical asymptote up 1 doesn't impact it. So I've got my vertical asymptote at x equals 0. I'm going to connect my purple dots. I'm going to eliminate any confusion by erasing those points, those pre-translated points. Erase those. My domain is my argument. Let's use a highlighter. Is my argument greater than 0? So x is greater than 0 would be 0 to infinity. The range always on logarithms is negative infinity to positive infinity, and my asymptote is still at x equals 0. So there's those 3 graphs. So hopefully graphing some basic logarithms with transformations, using a little bit of knowledge right here in case you don't want to use transformations or you want to check to make sure that you've translated properly, but you want to do it mathematically. So having both of those tools is very, very helpful.